Hi, to all structure engineers, steel connection engineer. Today I'm going to show you how to use our program, civil-based steel connection design program, to design the shear connection. All right. So I stop Google Chrome here. I type in the address asp.civilbay.com/connect. Okay, connect. Enter. Okay, I get the interface here. These under General tab, we change the moment connection to shear connection. All right. So the next selection, okay, is shear connecting member. It's there are three options here: beam to column flange, beam to column web, and beam to girder. Okay, for what what it shows now is beam to column flange. All right, see the left sketch. We can change to beam to column web. Okay, you will update to column web. Now it's to column web. Also can be beam to girder. Okay, beam to girder, right? So the next input is just called beam to girder top steel drop. Okay, we can have different top steel elevations between beam and girder. Let's say we drop it 2 inch. See the 2 inch drop there? Okay, the beam drop 2 inch. If we input the negative value, the beam top steel will be higher, 2 inch higher than the girder. Right, so now the beam top steel is 2 inch higher. -2, where's 2 inch higher? Okay, it's here. Okay, so because for the beam to girder, because the beam's top and bottom flange will be cope, either both or one of them will be cope when the beam connect to girder to accommodate the girder flange. Okay, so that coping reduce the shear capacity. All right, and to compensate that, sometimes we provide the horizontal stiffener, as you see here, to compensate the reduced shear capacity here. Okay, we see the horizontal stiffener plate here. That's one of the treatment here. All right, so we provide that option. Okay, so that options when you cope the beam top or bottom flange or both. Okay, we provide horizontal stiffener plate. Say we flush we get these top and bottom beam top steel same as a girder. We change back to 0 inch drop. Okay, no drop. So we go to beam to girder. We want to copy the suggest value to get a reasonable cope depth. Okay, we copy it. All right, so we get the reasonable copy the suggest value, and now the top and bottom flange get cope. All right, so we provide these options, adding the horizontal stiffener plate to strengthen the strengthen the weakened being shear capacity due to the coping, flange coping. Okay, we can turn it off. No. Okay. Now that's one option. Okay. So now come back to the normal. All right, without the horizontal stiffener plate. All right, so that's all of our options on the general tab, and go to section. It will be the same as the moment connection. You can set up the girder section and beam section. So when you go to beam to column flange, let's say now it's beam to girder, right? When you go to beam to column flange, okay. All right, beam to column flange, you can set up the column sections and beam section here. All right, you can set up the same as the moment connection. For this one, I believe the beam section could be channel. All right, so it could be C section. All right, channel, and the column can only be Y flange, I believe. Okay, so we provide an option for channel connect as a beam to connect as a shear connection. All right, so we go back to Y flange here. You have the option of design channel shear connection. Okay, so now we come to beam to column, which will specify connector. Beam to column. We have three type of connector. It could be end plate, as what you see now, end plate, okay, and it could be crit angle. All right. Crit angle, that's what you see now, it's crit angle, okay? It could be also shear tab, right? Okay, that's shear tab, okay? So we go back to end plate. I like end plate most of the time. So we have three types of shear connections. It could be connected by end plate, by crit angle, by shear tab. All right. So the rest, that one specified weld, that one specified end plate thickness, rows of bolts. Okay, you see the left side highlighted text. Okay, in yellow, shaded yellow. Okay, that's edge distance. That's the number of columns, the bolt columns. That's gauge, that's bolt spacing, that's edge distance in vertical direction, that's first bolt starting distance. All right. So this shear connection for end plate, we allow you to use these short end plate to be within the top and bottom flange. We also allow you to extend the end plate to get the flange, being flange welded. See that one? Okay. They're more like a moment, but whatever you want to treat it as shear, that's fine. Okay, we provide an option for that, and also we allow you extend the end plate further to add one more rows of bolts outside the being flange. Okay, add one more rows of bolts. See here? All right. That's more like a moment connection, but if you want to design it as shear, that's fine. We provide option for that. Also, you can add the outside stiffener plate here. All right. So for end plate, we provide that option. You can design this one as a shear connection. There's no problem for that. It's heavy shear or whatever you think. Again, so we could accommodate. We provide the option for you to stiffen the column web, okay, provide stiffener at the column web. Go to General tab. Okay, you could put yes, and there will be stiffener plate. Okay, see here. So for large axial load, okay, the shear connection, not only the shear, okay, the beam itself has many times have a huge axial load, either tensile or compression. So there will be due to this big, if the axial load is big, the column web creeping, buckling, let's see, the column web local yieldings, flange local bending, see here, this check item, and I will pull it down. Web local yielding and local bending, that's I believe for tensile force, but for compression force, actual tensile. Okay, actual tensile force, see that? For compression force, there will be, let's say, 125 compression. There will be other check item, limit state item. Now we get the actual compression. Okay, see here, 125 compression instead of tensile, what we see just now. Now, for this column web, there's column web, okay, come down. Column web local, no, pull it down again, okay. Column web local crippling, okay. Column web local yielding. So there will be some column web check with stiffener plate. There will help to get it passed, okay. Let's say general, go to general. So column web, local yielding, local crippling, these limit state. That's how these stiffener plate column web helping, okay. And we go to column stiffener plate tab here. We have the options, we have the multiple option. We have the option of providing two stiffener plate, okay. We can provide one stiffener plate only. All right. Okay, one stiffener plate, and we can set a stiffener plate thickness, width, creep, corner creep, and we can get a stiffener be full depth or half depth. All right. Here you go. Okay, so it's half depth stiffener plate. You can set a stiffener plate steel grade, the weld, okay, to the flange, weld to the column web. Okay, so that's column web stiffener plate options. We can turn it off. All right. We can turn it off by set that's no, okay, no stiffener plate. Okay. So go to beam to column, okay. Then we go back to, okay, that's heavy shear connection. It's more like a MC connection, but if you want that way, it can be designed as a shear connection. Okay, I mean, take the shear force and actual load, and we go back to the normal, most common seam, most common shear connection, with this end plate just to be within top bottom flange. All right, so that's a shear connection. Okay, so again, we can do end plate. That's what you see now. We can do creep angle and shear tap. All right, so finally go to design load, and it takes shear load and actual load. There's no moment here. So for the shear load, we have in plane shear load, as you see the highlighted on the sketch. We can also take the, for end plate only, we can only take the strong axis shear. We can also take the weak axis shear. Okay, weak axis shears, if it's not 0, let's say it's 25. Okay, 25 kips. You see the left. All right, you see the left. So the highlight one is weak axis shear. Okay, we have strong axis shear, weak axis shear. See the highlight. We also have axial. Okay, see the highlight. It's compression. If it's negative, it will be tensile. Okay, that's difference, because tensile, there's prying of the bolt. See, the ratio will go up 3.02. It's terrible fail. Okay, so the tensile is huge, and see what caused the fail. I don't know. Compression, let's say 125 kips. There's no problem. Okay, we go back to 0.84. So there's a big difference for the actual force in terms of tensile and compression, because the prying action. Okay, if tensile, the bolt will get reduced capacity due to prying if your end plate thickness is too thin. All right, so go to design calc again. So we can add a sketch. Okay, beam to column, we can add a sketch here. Okay, here you get a sketch. Okay, so end plate shear connections, we expand all the detail calculation is here, right? So this shear connection suite, they can design a shear force for both taking strong axis shear and weak axis shear, or they can take the shear in two directions at the same time. Okay, we have we have a stupid past project experience. The lead of the project, they want to get this shear connection to take shear in weak axis, which is not common same approach, because normally we get this shear, weak axis shear. Go to design load. Okay, see see the strong axis shear and weak axis shear. Normally we don't get these shear connection to take the shear force in weak axis. All right, but the project lead insists on assigning these shear connection with that capacity, and which give the steel fabricator a tough time to accommodate it. All right, so we normally get the horizontal brace to take all the shear in weak axis. Okay, the shear connection only take the strong axis shear. So anyway, for end plate, we provide the option for you to design the shear connection to take the weak axis shear. So there's combined strong axis, weak axis, and axial, either tensile or compression. All right. So we get these calculation part, sketch. All right. And we expand all. Okay, expand all. These all checking, let me stay check. Okay, so we print this calculation. All right, it's browser, just like you print web page. Right click and hit the print. All right. Okay, so now, all right. So this calculation, I print it to my PDF printer. All right, that's a nice calculation. And I hit the print. Okay, my first shear calculation. Okay, I changed to my first shear calculation. Save it. Okay, that one is generating PDF file. It's an end plate shear connection to beam to column flange. You can do beam to column web, beam to girder, and Also, the connector could be end plate, creep angle, or shear tap. All right. So we have we provide all kinds of options for you to design this shear connection. So here you go. That's a PDF file. We generate a shear connection. Okay. So these conclude our today's tutorial for you to design a shear connection. And we will see you next time for the brace connection. Bye bye.